In this lesson, we're going to be talking about layer 2 addresses. Many layers actually require addresses in order to be able to differentiate one object from another. What we've got here is a number of computer systems or other types of systems like routers or other devices that would sit on the network and need to be able to be accessed. So we've got all of these objects and they need to be accessed, so we need an address for them because we need to know how to get to them. Just like when you're getting a letter, you don't just drop a letter out there and expect it's going to get to the right place. You've got to put an address on it. If you want it to get to your friend who you're writing the letter to, you've got to put your friend's address on the outside of the envelope. Same sort of thing here. We've got an Ethernet header that you can actually think of as the envelope, and along with that envelope comes an address. You want to be able to make sure that if the letter doesn't get delivered, it comes back to you. So you need to put your address as well as the address that the letter is going to. Similarly, we have a source and destination address in our layer 2 header. What we've got here with Ethernet is actually a MAC address, and MAC stands for Media Access Control. The MAC address, sometimes called the physical address, is actually bound to the network interface card, which is why it's called a physical address, because it lives physically on the network interface card. We use this MAC address locally to deliver messages to one another. You may be wondering, well, we've also got IP addresses, so why not just use IP addresses everywhere that we go? The reason that we don't use IP addresses for all of our addressing needs is we need an address that's abstracted from the IP address so that we can use different networking protocols on top of Ethernet. So I've got Ethernet, and that's where my MAC address lives, is in the layer 2 header. I want to be able to use other networking protocols other than IP. So that's why we need a MAC address that's separate and distinct from the IP address. I need to have the ability to have other networking protocols like IPX, SPX, or AppleTalk, or DECnet, or some of the other protocols. We need that modularity. There has to be an address at layer 2 so that we can have different addresses at layer 3, and we're not required to just use the IP address. And it really protects the layer 3 protocol from having to implement all of the layer 2 pieces as well. So we do all of the stuff around the data link connection in the layer 2, which is where the Media Access Control or MAC address lives. What we've got here, you can see, is a destination and a source address, and the addresses are the same in terms of their structure. You can see the destination in the left-hand side says Netgear _CE:03:83. Now, what we've got in both of these is a 48-bit address. And the first 3 bytes of the address are related to the vendor. It's actually called an OUI, or an organizationally unique identifier. And what Wireshark has done very nicely for us is it has looked up that OUI, and it is determined that it is owned by the organization Netgear _CE. In the source, you can actually see the source is owned by Apple, and it's got a designation of Apple _E2. We've got the Netgear and the Apple devices that are talking to one another, and the second 3 bytes actually are the NIC address. So they are the unique address specific to that network interface card. So we've got 3 bytes that belong to the vendor. The E0469A, that belongs to the vendor in the destination address, and the CE0383 belongs to the network interface card. So that's the network interface card's address itself. And you put the two together and you get the MAC address. There are several different protocols actually that use MAC addresses. Ethernet is one. You can see here we're looking at an Ethernet packet. We can see the MAC address there. Bluetooth also uses MAC addresses. 802.11 Wi-Fi, Fiber interfaces like FIDI use MAC addresses, and ATM also use MAC addresses. So lots of different protocols use these same MAC addresses to identify the devices that are communicating back and forth. That's a little bit about MAC addresses and layer 2 addresses in general, but MAC addresses specifically. And MAC addresses are actually what we're going to see a lot of as we go through these different lessons and we look at different protocols. We're going to be seeing a lot of MAC addresses. We'll talk a little bit more about how MAC addresses are used and how the translation between a layer 2 MAC address and a layer 3 IP address, for example, happens, and how you do lookups based on IP address versus MAC address. That's the layer 2 address, and that's why we use layer 2 addresses as opposed to always using layer 3 addresses.